Hey guys, Miss Bankston here. For this session, we are going to be talking about atomic structure. This is Learning Target Matter 3, and there should be some pages in your notebook that go along with this presentation. If you have any questions at the end of this, make sure you ask before you leave. So, what I have here on this slide is actually a picture of one of the very first periodic tables. And we've been looking at our periodic table for a couple weeks. Our periodic table looks nothing like this. But this was sort of the process. So a little bit of guess and check. Notice there's a lot of scribbles in there, kind of hard to read. Trying to figure out how do we put all of these different elements in an organized way that is useful to us so that we can take advantage of the properties like we've talked about earlier in the year and kind of predict what these elements will do. From that, Mr. Mendeleev came along and he organized all of the elements by atomic mass, by how heavy they were, because that was one of the things that he could actually measure. So he created this periodic table where, notice there's a couple of things where he went, you know what, TH, maybe it's 118, I'm not so sure. Or over here, there's a question mark. He said, I think there's an element that should weigh 180. I don't know which one it is yet, but I'm still working on it. The problem with the atomic mass organization is that as far as properties went for these different elements, they weren't really lining up or making any sense. So we knew we had to look at reorganizing it at least one more time. The next periodic table that evolved is our modern table. And our modern periodic table, this one should look familiar to you. This is very similar to the one that you guys have in the back of your notebook. And this periodic table is organized by atomic number. Okay, and we're going to talk about what that is. But you can see that number indicated in the top left corner of each of these elements. And if you read this like a book, left to right, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on all the way down. Okay, and we notice that when we organize the elements by atomic number, now we're starting to see some patterns with the properties of these elements, and we're going to talk a little bit more about that. So what scientists figured out as they started organizing and reorganizing this periodic table is that there's actually smaller pieces that make up an atom. There's 3 different pieces inside an atom. We have protons, neutrons, and electrons. And you should have this chart to fill in your notebook. Okay? First thing we're going to talk about are protons. Down here on our chart, the blue center is going to be the nucleus, and the yellow will be the electron cloud. Okay? So protons are positively charged. We're going to represent them with little pluses. And those are found in the nucleus. So notice the pluses are in the blue circle. Those little positive charged particles are heavy in the world of atoms, not probably heavy compared to what we think of as heavy, but they're a heavy subatomic particle, and subatomic means smaller than an atom. So there's 3 subatomic particles, protons being one of them. Next subatomic particle is a neutron. Neutron has no charge, so we're going to represent those with a 0. They're also found in the nucleus, along with those protons. Okay? And they're just as heavy as those protons are. So both of these are going to contribute to the mass of the atom. The last little bit are the electrons. Electrons have a negative charge, and they are found outside the nucleus, and this we call the electron cloud. All right? And electrons are really, really teeny, teeny, tiny. So teeny, tiny that they weigh almost nothing. So when we're figuring out the mass of an atom, we don't really include the electrons in that mass. It's kind of like, you know, if you wanted to know how much you weigh, so you step on the scale, and while you're standing on the scale, one little speck of dust falls on your shoulder. It's probably not going to change what the scale says because that little particle of dust is too small to really have any influence on your mass. So that's very similar to an electron. Although they're in there, they're so teeny tiny that their mass really doesn't contribute at all. So we say that they weigh almost nothing, or sometimes we just pretend they weigh nothing. So which part of the atom weighs the most? The nucleus or the electron cloud? What do you think? Hopefully, you said the nucleus. The protons and the neutrons are both found in the nucleus, and those are both the heavy parts. The only thing found outside in this electron cloud is the electrons, and they weigh almost nothing, so that electron cloud hardly has any mass in it. All the mass of an atom is found right here in the middle. Okay, now we also know that atoms are always electrically neutral, meaning that overall they're not going to have a positive charge or a negative charge. Now, the only way that that is possible is if the protons and the electrons are always equal. So that's saying for every positive charge that we have in our atom, because remember protons are positively charged, we also have an electron in the atom to cancel out that positive charge. So for each positive charge here that we have in the nucleus, we have a negative charge floating around in the electron cloud. Notice for this atom here, we have 1, 2, 3, 4, 5, 6 positive charges in the nucleus. And then we have also 6 electrons, 1, 2, 3, 4, 5, 6, floating around in the outside. For each positive charge, there's a negative charge, and if you take a +1 and a -1, that equals 0, no charge. So +6 and -6 would give us a 0 charge overall for this atom. Okay? Now, we need to be able to use our periodic table to help build an atom. And one of the things that's going to be really important on the periodic table is the atomic number, usually found at the top of each box for your element. I would label this in your notes as the atomic number. And the atomic number tells us the number of protons in an atom. So this is carbon. Carbon has 6 for an atomic number, which means there are 6 protons in the center. If we count 1, 2, 3, 4, 5, 6, yep, that matches. So we know that this atom is carbon. That atomic number is what will give an atom its identity. So anytime an atom has 6 protons in the middle, it's always a carbon atom. And protons, the number of protons will never ever change. So sometimes, and we'll learn about this later on, sometimes we can change the number of neutrons because they don't have a charge on them. And sometimes we can even change the number of electrons in an atom. But we can never change the number of protons. If you add a proton to carbon, then it's going to have 7 protons. It's not carbon anymore. Now it's nitrogen. And it'll act a lot different than carbon. Okay, so look at your periodic table and see if you can figure out what the atomic number of magnesium is. Okay, pause the video, and when you're ready to reveal the answers for magnesium, and look up oxygen too and see if you can figure it out. Try to figure it out on your own and then check your answers. Hopefully for magnesium you found that the atomic number of magnesium is 12. So that means there are 12 protons in the middle for magnesium. Oxygen has an atomic number of 8. So only 8 protons in the nucleus for oxygen. Really quickly now, try again to figure out which element has 7 protons, 35 protons, and 10 protons. Pause the video, give it a shot on your own, and then check your answers. The element that has 7 protons is, should be nitrogen. 35 protons should be bromine, Br. And 10 protons should be the noble gas known as neon. Hopefully you got those right. If not, recheck your atomic numbers on your periodic table and see where we went wrong. Another thing that the periodic table is going to tell us about our atom is the mass number. And this is found on the bottom of each box for an element. You should label this in your notes as well. Now the mass number tells us how heavy an atom is. What is the mass of that atom? Now if you remember when we were talking about the subatomic particles earlier, we said that electrons weigh almost nothing. Okay, so that means that protons and neutrons, those are the heavy things. Those are the parts that we're going to include in our mass number. So our mass number is equal to protons plus neutrons. Okay, however, and we're just counting, so it's the number of protons plus the number of neutrons in the nucleus. In other words, it's how many things are in the nucleus. We count them up, that gives us our mass number. So a question for you then is, why don't we count the electrons? Well, hopefully you know that that's because they're too light. So we go through this and we can try to figure out the mass number of these atoms. Again, everything in the nucleus contributes to the mass because the protons and the neutrons are the heavy pieces. So we can just count the particles in the middle and that will give us our mass number. So for this atom we go 1, 2, 3, 4. Mass number is 4. Over here, protons and neutrons, 1, 2, 3, 4, 5, 6, 7. Mass number is 7. 3 of that particles are protons and 4 of them are neutrons. If you take the number of protons, 3, plus the number of neutrons, 4, and add them together, you get 7. For this one, number of things in the middle, 1, 2, 3, 4, 5, 6, 7, 8 particles in the middle, so the mass number of this is 8. Again, we're not counting the electrons because they're too light. So you're going to see a lot of charts like this where you have to be able to figure out what element it is, what the atomic number is, protons, neutrons, electrons, and I'm going to leave some information out. So for instance, you have beryllium. The symbol for beryllium is Be, and if we look at our periodic table, the atomic number for beryllium is 4. The mass number for beryllium is 9. Okay, and we know that, okay, for these we can figure it out based on the atomic number and the mass number. So atomic number tells us the number of protons, right? So if our atomic number is 4, we know that our number of protons is 4. We also know that protons are always equal to electrons, so we can go ahead and put a 4 over here as well. And here's a hint. Atomic number, protons, and electrons are always going to be equal. 4, 4, 4. Okay? We also know that mass number is your protons plus your neutrons. So here 4 plus 5 equals 9. Okay? You might want to write that above your chart in your notes. Okay? So we go through these. O would be oxygen. And the atomic number of oxygen is 8. And the mass number I gave to is 16. Now, if the atomic number is 8, it means we have 8 protons and 8 electrons. All 3 of those are always equal. Now, we know that the mass number is 16. So these two numbers added together need to equal 16. 8 plus what is 16? Answer is 8. Okay, try the last one on your own and then check your answer. Potassium. Symbol is K. Atomic number for potassium is 19, which tells us the number of protons is 19 and the number of electrons is 19. Now remember, our mass number is going to be these two put together. So 20 plus 19 is 39. Okay, hopefully you got all of those right. And that is it for our atomic structure. Again, if you have questions or you struggled with getting some of the answers right on here, make sure you're asking for teacher help while you're in class. And feel free to move on to the practice from here.